Okay, today I have a little problem for you. The problem is that there's two trains that are in danger and they're traveling on the same track. Well, the equation we're going to use is rate times time equals distance. So it's 1 a.m. in the morning. Two trains leave stations from cities 440 miles apart. Train A travels at a constant speed of 30 miles an hour, while train B travels at a constant speed of 50 miles per hour. Unfortunately, they are on the same track, and we need to know how long we have to correct the mistake before there is a disaster. Can we go to sleep and take care of the problem in the morning? Well, the first thing you want to do is note that algebra can be used to the rescue. Let's list the data and develop the equation. And let me make my little guy go away here. Then we can solve the problem. So we're going to list the data, develop an equation, and then we can solve the problem. Here's the data. Distance of the cities, 440 miles. Train A is traveling at a rate of 30 miles per hour. Train B is traveling at a rate of 50 miles an hour. Well, the departure time is 1 a.m. Now, to develop the equation, you need to set up a box with all the information. From the box, the equation will be evident. So let's see, we'll set up a box and we'll put the data inside the box and see what happens or develops. Here's the little box that I set up. Now, notice that you have rate times time equals distance. This is paramount to solving this problem. We have a train, we have the rate that the trains travel, we have a time, and we have a total distance of 440 miles. Now note, train A is traveling at 30 miles per hour, and time we don't know, so we use a variable, t. I guess t is the best one. We could use x or y or any other variable, but t seems more appropriate. And following the equation, rate times time equals distance, we develop the distance that train A is traveling. 30 miles an hour times t gives you 30 times t. That's the distance that it travels. Train B, likewise, is traveling, but now 50 miles an hour, and t would be the time, because they're both going to travel the same time, even though their distances are going to be different. The equation that develops is 30 plus 50t equals 400. Then we want to solve for that equation. So solution to the equation, you take 30 plus 50t, both 30t and 50t equals 440. You combine like terms, so you get 80t equals 440, and then divide both sides by 80. Your time t is 5.5. Now, what does that 5.5 mean? It means 5.5 hours. The conclusion is two trains will make contact in 5.5 hours after departure from their respective stations. Since the trains left at 1 a.m., we conclude that the time of a possible collision is 6:30 a.m., and going to sleep would be the wrong decision. I hope that helps. Now, I offer tutoring online, available subjects, pretty much any math that you wish to have. And you may call me at my numbers, 302-855-0615 or 302-228-7555.